Hey everybody, back at it again. Let's do the end of chapter 4. So we'll call this chapter 4 part 2. We're going to touch on taxes, and there are a few basic concepts we need to nail down. Statutory and economic incidence, or burden, they're often referred to as. Talk about revenue generated from tax, and then we're also going to talk about the efficiency impacts of taxes. Let's jump right into burdens. The first kind of burden that we're going to talk about is a statutory burden. And this is quite simply who's responsible for sending payment to the government. And we can show this with shifts of the supply or the demand. Let's start out with the firm. The firms are almost always asked to remit payment just because it's easier to keep track of a smaller amount of people. There's lots of consumers. So if the firm has to submit a payment to the government, a tax, let's say that it's a simple tax, fixed dollar amount per unit, or an excise tax, then we're going to shift their supply curve to the left. And what we're indicating here is that the only way that those firms would be willing to supply the same amount that they're currently supplying is if they could raise their price by the amount of the tax per unit. Similarly, if you ask the consumer to remit payment to the government, then we would shift the demand curve to the left, which is simply indicating that the only way they'd be interested in the same amount of quantity is if they were able to pay a price that was lower by the amount of the tax. So we end up with a couple of intersections here, new equilibriums. And I don't want you to get thrown off by the fact that it looks like there's different solutions here. On the bottom graph, down here for the consumer, this is the price that they actually are going to end up paying the producer. But they have to still submit payment over to the government. Up here on our top graph, this is our price that's received by the producer, but part of that price then has to be submitted back to the government as a tax. So in either event, we're going to find out that the economic burdens do not change depending on who sends in payment. So we're already drifting. Let's just go there. Let's talk about economic burdens. The general public often talks about a tax, and they talk about it in terms of statutory burden. There's a tax on so-and-so, and that means they have to pay it. They're right if they mean they have to send the check to the government, but they're probably wrong if they mean that that party has to pay the entire tax by themselves. In both the cases that we've looked at here, suppliers wanted to raise their price by the amount of the tax, and consumers would have liked to have lowered the price they pay by the amount of the tax. The only problem is, in order to get a transaction done, you need a willing buyer and seller. And if suppliers try to raise prices, they're going to lose some customers. They will not sell the same amount that they used to. And over here, if consumers are trying to lower the price they're going to pay, they're not going to find willing sellers anymore. This is going to end up in a situation where they are forced to actually split the burden of the tax. And statutory burden, I should say they're going to split the economic burden of the tax. The statutory burden really is pretty irrelevant unless you're interested in who's sending a check. When we talk about who actually ends up paying the tax, we're referring to economic burden, and we're going to show this with what's called a wedge. We'll look at that on the next slide. Okay, so let's look at economic burden and that wedge. In our last slide, we noticed that if the supplier had to remit payment, then they were going to want to move the supply curve up by the amount of the tax, and we got an intersection. And if the consumer had to remit payment, they wanted to move their demand curve down, and you ended up with two different intersections. What I want you to realize is that these two are actually vertically right over the top of each other, and I want you to connect the two of them together with this line. We're going to refer to this as the wedge. The wedge is incredibly useful because it's telling us essentially that it doesn't matter that the supplier wants to pawn the tax off onto the consumer and vice versa. It's basically indicating that in order to find willing buyers and sellers, they both have to move on their prices, right? So in our situation, the consumer wanted to drop the amount of the price they were willing to pay by the value of the tax, and the supplier would have loved to have raised their price by the amount of the tax. So we know for a fact then that this vertical distance between the red and the blue is actually just a vertical distance that is equal to the tax. So let's pencil that in here. Right? Our tax per unit is equal to the height of that wedge, that bar that we threw in there. The other thing that's really nice about the wedge is it signifies where they end up after they sort of haggle over the prices and decide what they're willing to buy and sell. The top part of the wedge is going to give us the price that the consumer actually is going to end up paying. And the bottom part of the wedge is going to end up giving us the price that the producer actually gets to take home. So our red dot on the graph here, of course, was where the demand created a new equilibrium, and that was the price that they were willing to pay to the producer. We've got that here. Then they had to submit the tax on top of that, which is why we end up here at PC, which is the amount that they actually pay once they've paid the tax. And you could flip it around the other way, right? We could talk about the PC as the amount that the producer originally collects, but then they have to give the tax away to the government, which drops their price back down to PP. Point being here is you can see who actually is bearing the burden of a tax. And in this case, it's actually split pretty equally. You can tell that because the consumer used to be able to buy this product at the equilibrium price, and now they're actually paying this higher PC, the price the consumer is paying. The producer used to sell at the higher equilibrium price, but now are accepting a lower price of PP. So the vertical distance between equilibrium and their respective prices shows how much of that tax they're actually paying. You can also think about this in terms of consumer and producer surplus. This area that I'm going to put in here in green is actually the revenue generated by the tax. We'll come back to that in a second. But that revenue is going to go to the government, and it has to come out of somebody's pocket. This portion here is coming out of consumer surplus, and this portion here is coming out of producer surplus. You can see that their losses are roughly similar, and the reason that's the case is that the absolute values of their slopes for their curves are relatively similar. Okay. As a final closing point for this slide, I want you to focus on the fact that the wedge is a convenient and easy way to see who actually ends up paying higher prices or receiving lower prices, which is the substance of economic burden. Compare the price they actually pay or receive to the old equilibrium, and you understand the actual economic costs of that tax for the individual or the firm. Okay, hopefully you understand the difference between statutory and economic burden at this point. It's going to be useful for us to actually delve a little further into the impacts of a tax. The minute that the tax was put into place, we recognize that the producer is now going to receive less than they used to for the product, and the consumer is now going to pay more for the product than they used to. So you can count on these things as natural results of almost all taxes. The one that we haven't highlighted yet is that this is going to have a quantity impact as well. Before the tax, we were transacting this amount. Let's call it QEQ. After the tax is in place, it makes sense that we're going to transact less, because if the product is getting more expensive for consumers and producers aren't earning as much for producing that product, then neither one of them has the incentive to consume or produce as much of that product as they used to. If you follow directly down from your wedge, this will give you the new amount of quantity that actually is going to get transacted after a tax. And of course, you can see that the quantity has fallen. For those of you who are catching on quickly, you probably recognize already that this triangle here is going to be deadweight loss, because these are transactions that no longer happen now that the tax is in place. If we have a tax per unit that's been levied on this product, then we're going to charge that tax on every single unit that gets sold. On our last slide, we talked about how this rectangle was going to be the revenue to the government, and it would come out of the consumer and the producer's pockets. The way that we know that this box here is actually revenue is because we are going to take the quantity that's sold and we are going to multiply that by the tax. And we know that the height of this box is equal to the height of the wedge, which is equal to the tax per unit. The base of this box is equal to the quantity that gets sold. So tax per Q multiplied by Q leaves you with tax revenue. This green box is the amount of revenue generated for the government. And you can figure out the exact dollar amount by literally taking the area of that green box. So we've got a couple of things that we've figured out here. Taxes are going to cause an overall drop in quantity, and that's going to lead to some inefficiencies. There will be natural deadweight loss that's associated with any tax. Now, of course, the upside is that this generates revenue for the government to take care of public goods, any other sorts of things that are necessary for the government to deal with. Okay, so we've covered all the basics. I do want to show you one result that we didn't cover in the last slide, but is going to be interesting to you. Not all taxes are created equal. They sometimes spread the burden very unequally between consumer and producer. And as we'll see in the next slide, some of them don't generate a lot of revenue, and they do create a lot of deadweight loss. Let's start out with an unequal sharing of the burden. I told you early on that PC and PP would be determined by the slopes of the supply and demand curve. Let's look at a couple of situations here where the two functions have pretty drastically different slopes. Situation like the left here, good example might be parking spots. And if the city of Seattle decides to start levying a tax on parking spots, then we would need to come over here and impose a wedge equal to the amount of the tax. Of course, the top would be the price for the consumer, the bottom would be the price for the producer. You could compare that to the old equilibrium price, and in this case you'd see that the consumer is not going to end up paying very much of this tax, whereas the producer is going to take a beating. And this makes sense because if you own a parking lot, it's probably pretty difficult to immediately do something different with a parking lot. So it's going to be tough to duck that tax. Consumers, however, the minute the tax goes into place, are just going to start taking the bus. They might carpool. You'll just see less parking spots probably getting rented. So here's one where the burden falls almost entirely on the producer. Over here, you could look at something like a market for insulin. And if you had a market for insulin and you decided you wanted to tax that, then you would have a situation that's pretty much the exact opposite. Drug companies could probably pretty easily manufacture other kinds of drugs, so they are somewhat able to duck this tax. They'd be able to move their resources around. However, diabetics would be in real trouble. So if you went and you imposed a tax, that tax would be very unequally shared. You would have the price for the producer falling almost not at all, and you would have the price for the consumer actually skyrocketing. So here's one where you have an unequal burden that falls on the consumer. Moral of the story, whoever has the steeper curve, they're the more insensitive, and they're the ones who are going to get stuck with the majority of a tax. If one of the curves is actually vertical, perfectly vertical, they're going to get stuck with all of the tax, period. It's pretty unusual. These are more normal circumstances. All right, so let's look at revenue. And not all taxes are created equal in terms of their ability to generate revenue efficiently. And not all taxes are actually aimed at generating revenue. Some of them are going to be what we're going to call a sin tax. And a sin tax is aimed at punishing people for a behavior and trying to get them to stop it. We'll tackle that in a second. Let's deal with revenue first. So this graph here on the left, we've got a tax that we're going to put into place. I'm going to draw in a wedge. And when we draw in that wedge, we're going to be able to immediately trace out what we know will be the revenue, because of course the quantity that we actually transact after the tax multiplied by the tax per unit is going to give us the dollar amount generated for the government. This is a pretty good revenue tax because you've got both curves that are pretty steep. Really, you just need one of them to be relatively steep, and it works out just fine. But there is going to be that inevitable deadweight loss. So this deadweight loss in here has to be measured against the revenue that was generated. This looks like it's a pretty good revenue tax. Okay. Over here on the left, if we took this same exact size of a tax and we threw that in here, I'm going to try to get this height exactly the same. If we threw that in there, it would be the same dollar amount per unit, but look at what's happened over here. This was our equilibrium, and look how much Q has fallen by. It's pretty tremendous. And of course, that means that there is a lot of deadweight loss, right? Deadweight loss over here was relatively small. Now, if you compare that against the amount of revenue that would actually be generated, and this tax doesn't look nearly as attractive, right? Whole lot of inefficiency for about the same amount of revenue. Now, if revenue is your game, then the situation on the left is economically much more efficient. But if you're actually putting the tax into place, not for revenue purposes, but you actually are going to want to try to drive out a behavior, then the graph over here on the right actually looks like you're going to be more successful. Because, of course, with the sin tax, the point is to drive quantity down. Over here, quantity has barely fallen at all. This, of course, is a wildly unsuccessful sin tax. So think about what your goals are for a tax, and you can sort of evaluate how well it's doing with your wedge, and you can compare your tax versus your deadweight loss. Revenue tax, this is a good idea. Sin tax, this is what you're looking for. Okay. Thanks, guys.